So, welcome back. Now, let us see table 3 actually, and let us look at the properties that the table 3 gives. So, table 3 subcooled and superheated zone, and this is how the table 3 looks, and this is what we had seen earlier when we browsed through the steam table or table 3. What you can see from here are different things, and let us go one by one through all these things, and let us try to understand what do they represent. So, first important thing is the properties that table 3 gives. So, you can see that the properties are, because we are talking about single phase region, subcooled region, superheated region, we are not talking about Vf and Vg over here or Uf and Ug, which is what we encountered in table 1 and table 2, because they were talking about LV region. They were talking about LV saturation line 2 phase region, and therefore, the 2 phase region came into existence over there, and therefore, we have to read the properties of saturated liquid and saturated vapor in those cases. Here, because we are talking about single phase region, I got only V, U, H and S here. Also, this snippet I have shown just partly, and that is why I have not shown up to 100,000 degrees centigrade. Alright. So, you can see all these properties with their respective units. Also to be noted is at 0 degree centigrade, this is for pressure of 0.1 MPa in this case. At 0 degree centigrade, we have got the properties of U and S as shown negative in this case. Alright. If you remember, earlier we had said that at 0.01 degree centigrade or the triple point, these values were assumed to be 0 because that was our reference point. Although the pressures are different in this case, U and S mostly depend on temperatures. With reference to that, this point has come negative in this case, while enthalpy also is very close to 0 in this case. Well, of course, depending on the thermodynamic state, the specific volume will be determined for this pressure and this temperature. Now, this is our PT diagram, and with reference to this PT diagram, we can understand what is all shown in this table 3. As I have shown here, this page is for pressure equal to 0.1 MPa. So, this is, I just draw a horizontal line here for pressure equal to 0.1 MPa. This page gives the properties of all the states that lie on this line. Also see here in this title is given Tsat value. So, this is Tsat value at 0.1 MPa. You understand this 0.1 MPa is close to atmospheric pressure 1 bar, and corresponding to that thing we have got Tsat P is equal to 99.606 degree centigrade, which is very close to the boiling point of water, which is 100 degrees centigrade. Alright, and that will come at 0.1016 whatever MPa, which is the correct pressure, atmospheric pressure. Corresponding to that would have come the Tsat P equal to 100 degrees centigrade. So, this is our reference system which lie on this table. Now, as you see, because this pressure happens to be less than critical pressure, if I went on increasing the temperature, I would encounter a phase change, which is what we had talked in the earlier snippet. So, what you see here, as I go on increasing the temperature, I would travel from this leftmost point of 0 degree centigrade to the higher temperature values, alright. So, this part up to the Tsat value, which is over here, that lies on the left side of this LV saturation line. So, here we say that because T is less than Tsat P and Tsat P happens to be 99.606 degree centigrade, and if we identify the zone, in this case this blue square, all these temperatures are less than Tsat P, and therefore, all these states lie in a subcooled or compressed liquid zone, alright. So, this entirely happens to be in a subcooled liquid zone, And if we go beyond 99.606 degrees centigrade, or if we go beyond T sat P value, we are in a superheated vapor zone. So, this entire second part is in a superheated vapor zone now, alright. Now, if I just take for example one value which lies in a subcooled zone, subcooled or compressed liquid zone 50 degrees centigrade, this point would be over here. So, corresponding to this value 50 degrees centigrade and 0.1 MPa, I will get all the property data from this table, alright. So, I get V, U, H and S for this single phase subcooled compressed liquid zone, the state which lies at this point. If I go increasing the temperature now, I will ultimately hit the phase change region, the LV line, where I would encounter phase change. So, if I go on increasing the temperatures at 99.606, I got the values over here, and these are the values of saturated fluid, alright. The first point, because I am travelling from subcooled liquid zone or compressed liquid zone, when I go on increasing the temperature, I will first hit the saturated liquid line, and the properties of saturated liquid line 100% liquid will be taken from this first temperature 99.606. So, these are all my Vf, Uf, Hf and Sf. And the next again the same point 99.606 is obviously saturated vapor line, and what I get here is all Vg, Ug, Hg and Sg. And I can tell you one more thing, that the difference between these two will be the HFG, SFG, delta U or delta V or VFG and UFG, as whatever you call it. So, these are the properties of saturated liquid and these are the properties of dry saturated vapor. So, I get all the F and G point from this, and this T sat value is also shown over here. Now, why did we encounter these values over here? Basically because this pressure happens to be less than the critical pressure, and we started from 0 degree centigrade onwards and we went on increasing the temperatures over here. Now, let us take one more example which is in superheated vapor zone. So, you can see the properties at 115 degrees centigrade, that will be given by this point, and we can have one more point 400 degrees centigrade. The temperature is more than the critical temperature in that case. So, all the properties at 0.1 MPa and different respective temperatures, I get all the properties for the single phase region, subcooled compressed liquid zone and superheated vapor zone. Also, I can get the values for F and G at T sat value as given over here. Thank you very much.